This particular question is gotten from SS1 scheme of work, precisely second term. Is on kinetic theory of matter. If you know your kinetic theory of matter, this question should be a very cheap one for you. It says in a fixed volume of a gas, an increase in temperature results in an increase in pressure due to an increase in the dash. Now, let me analyze this very well. What happens in our kitchen? This is a pot of water, and you are heating it here. Heat. Once you start heating it, once it starts boiling, vapor will start forming. Then, when you close this pot, a time will reach when the cover of this pot will start vibrating, meaning that the molecules have gathered enough kinetic energy to be pushing on the wall of this container and on the cover. That is why the cover starts shaking, 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 shaking. What has happened? There is an increase in the quantity of heat, which is increase in temperature. And this leads to increase in pressure. Pressure means to press. The ability of these energetic molecules of vapor to press on themselves and press on the walls of the container increases. And that is why at a very high temperature, the cover starts shaking. Because the vapor themselves want to escape. Because the kinetic energy is on top gear and the random movement there has increased. So the collision among themselves and with the walls of the container has increased. Now, let us go back to the options and see what they are. Let's go back to the options. Now, check the options. In a fixed volume of gas, an increase in temperature results in an increase in pressure due to increase in what? What causes that pressure? A. Number of collisions between gas molecules. Yes, number of collisions between gas molecules is the result of the increase in pressure. B. Number of repulsions between the molecules involved. Number of repulsions? No. It's not about number of repulsion. It is number of collision actually. But look at this A and C. They resemble. Number of collision between the gas molecules and the walls of the container. This A should have been the answer, but it is talking about number of collision between the gas molecules themselves, neglecting collision of the gas molecules with the walls of the container. So this C should be the answer. Number of collisions between the gas molecules and the walls of the container.